Hey guys, so today we're going to talk about the 5 types of reactions, um, and kind of just how to identify them. So first off, here's just the names: combination, decomposition, single replacement, double replacement, combustion. And we've used combustion before on the balancing one. So combination, first off, it's when two substances, usually elements, combine and form a compound. Just sometimes they're called synthesis or addition. That's just what you could see, in a book again, if we were to open it. I call it a reactant plus a reactant equals one product. And it's just two things, like individual things. That's why it's two things make a compound. And it's just one. Okay, so these are just a bunch of examples. And this is all we're gonna do. There is a type where you have something combining with water. But okay, so if you notice, one element, compound, element, compound. Does it matter that there's just two here? No. Why is that a two? Because it's a Hofbrinkel. Hof. How many BRs? But anything else, single elements, are just by themselves. Just the Hofbrinkels get the twos. And then over here, they just form the compounds like switching the charges. This one I would have to tell you what the charge is, but anyway. Okay, so visuals. Now this is my favorite. So you get cartoon visuals is what I start off with. A skinny bird eats a worm and becomes a fat bird. So they combine and make one. They combine and make one. Oops, that didn't. And then this is my visual. I love this. These are the particle level diagrams that we do all the time. So potassium is a metal. All it is a bunch of potassium ions. Chlorine's a gas, so it's flying all over the place. But when they combine, they become a solid. So that's what this picture is. Chlorine is that funky brown gas, and apparently it's pretty. And then type 2 is decomposition. Funnily enough, it's just the reverse. So a compound breaks down into two elements, or really it should say a compound breaks down into two components. But usually, like, these don't happen spontaneously most of the time. You have to add heat or electricity or a catalyst. One reactant breaks down into two products. General form again. So A, B together, like each letter is an atom or ion, makes A plus B. Type 2 examples. So just a bunch of examples. See, and funnily enough, it's just the examples from before breaking apart. One thing breaking apart into its elements. This thing breaking apart into its, right? So it's one thing breaking apart. Again, visuals. You got a whole egg and it breaks apart into a half an egg in a turtle. And again, visuals. This is mercury oxide, so this is no longer in schools, but if you heat mercury oxide, it turns into these two things. FYI, when we did that Dalton's Playhouse, calx. This is the calx. That's what it was. Breaking down into mercury metal and oxygen gas. Mercury metal, oxygen gas. Single replacement. You have a single element taking the place of another in a compound. Element plus compound equals element plus compound. Again, the general form is each letter is like an element and or ion. A takes the place of B in the compound. And you can write that B plus AC. It doesn't matter what order they're written in. That single element takes the place. So I did more specific. It's a metal plus a compound makes a metal plus a compound is really what happens. And again, there's one example, but here it is again. Again, a bunch of examples. The aluminum is taking the place of the copper. The lithium is taking the place of the calcium. See? And again, see, aluminum's, it's like this guy kicks out that guy and makes this. There is a kind where you have a non-metal replacing a non-metal, but we're not even going to worry about that. We're only going to do metals. Visuals of single replacement. So you got the single guy with the single, see, like replaces like is how single replacements work. So the guy replaces the guy. So see, he takes the lady's partner. And again, visuals, this would be lithium reacting with water. And again, this would be water as HOH, which is why it becomes LiOH and H2. That's just, that's kind of a confusing one. There's other ones. Actually, I'm going to do demos with these things on the review. Double replacement. So funnily enough, the negative portions is my definition. It's not even a book definition. The negative portions of two ionic compounds are interchanged or switched. So again, each letter is a part. I said negative portions because it could be an element or it could be an ion. Like it could be a sulfate, one of those polyatomic ions. So A, B, C, D. So do you notice the metal or the first thing stays in its place and just the second thing switch? You see that? Again, a bunch of examples. So these were just single elements, but I could, like this could be Na2SO4, and it would be CaSO4 plus NaBr. Like it could be polyatomic ions, but really, okay, so there we go. And then visuals, so the guys switch their hats. So I'm pointing with my finger and you can't see it, so the hats switch. It's not like people's faces switch, like it's not like it's the negative portions, just the same thing switches. It's not like the two faces combine, because that would be weird. So double replacement. Now this, I love this visual, and I'm probably going to use it on the review. This is what happens. All those reactions that we did with at the very beginning of the year, where we mixed the two liquids and it made a white solid. All those precipitate reactions when we did how reactive the alkali earth metals were on the periodic table. Like a solution is a bunch of water with the individual ions. Oh, I talked about them with the bonding, that when it dissociates, you just have the individual ions floating around, right? So the water is pale because that's not what reacts. But what happens is when you mix these things, this is kind of confusing. It would be like all this solid stuff sinks down to the bottom of the beaker, and then this stuff still stays floating on the top. Like one thing becomes a solid, so it sticks together like that, and the other stuff just floats there. So if you notice, it's the Ba and the CO3 that made the solid, and the other guys are just floating around in solution, and that's what double replacements happen. The last one is combustion, a hydrocarbon. So, okay, don't think too hard. Hydrocarbon. You might think water, but a hydrocarbon is a carbon hydrogen compound. And what does it do? It rapidly combines with oxygen to produce carbon dioxide. And what is that really? Burning. Anything that burns. Okay, that's a lie. Not anything that burns. But if something's burning, it's most likely a combustion reaction. And so hydrocarbon. So see the X and the Y, and I'm sure it could be any number. It could be C2H4, just CH2, like C7H25, like whatever. This can be any numbers, but you have a CH and an O. So the examples are going to be really boring, like a CH and an O makes CO2 and H2O, CHO, right? Like, and funnily enough, every single combustion reaction just makes those two things. Okay, and then this is the simple way to recognize. So a combination reaction will only have one product. Like you'll see a plus sign on this side of the reactant, and then one thing over here. A decomposition will have one reactant, so one thing over here and a plus sign over here. Single replacement, you will always see an element and a compound on both sides. A single element and a compound. Double replacement, you'll have two compounds and they'll switch places. So really this should say a single element plus compound on both sides. Double replacement, you'll see two compounds on both sides. And then a combustion reaction, the key part is really actually the whole thing. Just the CH plus O2. Pretty much if you see a CH compound over here, it's a combustion reaction. There's like no guessing. So there you go. The homework is going to be it's a bunch of matching questions and then some balancing questions. So I would really like to do more with chemical reactions, but we have like 2 weeks after this, and I really want to do stoichiometry. So this, I'm just going to end chemical reactions right here. My daughter's laughing. On the review tomorrow, though, I'm going to do it. Tomorrow's going to do a bunch of demos. So it'll be review/demos. And the only thing I'm going to put on the quiz is going to be this. Can you identify reactant? Can you identify what the reaction is? And can you balance? So that's really all we're doing for chemical reactions. I'm going to do some demos, though, with the review. Actually, I'll probably teach how to tell single and double replacement reactions, but I'm not going to test over that. So that's what I'll do with the demos. So good luck with today's stuff. It'll be multiple choice, maybe matching. I might even try to make matching flashcards on the Nearpod, but that might be in the too hard basket because it's kind of late already. So good luck. We're going to finish out this week and do one more week, and then I'm going to call it good. We're not going to, last week of May would be finals. And I'm not gonna, I might do a farewell, look at all the fun demos I can do, but I'm gonna call it good. Thank you for sticking in with me, guys.